Hey everyone, it's Justin here. I'm going to use math to show you how secure your password is. With that being said, let's go straight to it. Now I know I don't have the most amazing setup, but this is going to be clear enough for you to see. So a good computer can crack 100 billion passwords per second. 100 billion passwords per second. Now let's assume you have only lowercase and your password length is 10 characters long. I'm just going to use Bruno because Bruno is 5 characters, so I'm going to use it twice. So B R U N O, that's my dog's name. And let's just mix it up. So let's do like another O R O B U. So that's my 10 character password. Now we want to see how many combinations there are for a 10 character password. So for the first letter, there's 26 options that a computer checks, right? The second letter, there's also 26 letters it checks. And so on and so forth for the next 10 letters. So this is 26 to the 10th power because we're multiplying because we want it all done at the same time. So it's 26 to the 10th power, which is roughly, this is roughly 1.411 times 10 to the 14th power. So this is how many times or how many characters or possible combinations of a 10 character password that it has to check. So if it checks 100 billion passwords per second, this is what we do. We take this number, we divide it by our 100 billion passwords per second. So we're going to divide it by 100 billion. And this is going to get how many seconds it takes to crack our 10 character password that's all lowercase. So this is roughly 1,411 seconds. And if we divide that by 60 one more time, we're going to get roughly about 24 minutes. So if your password is 10 characters long, all lowercase, a computer is going to take about 24 minutes to hack your password. Do you feel secure now? Now I'm going to show you the math for if your password is longer. So before we had 26, because there's 26 letters in the alphabet per slot. So if there's a slot here, that's 26 different combinations there, another 26 here, and then another 26 here. So whatever letter we choose, there's 26 different options. We're only choosing one in that spot. So, and then we multiply these to get our total combinations, whatever that is. So if our password is 15 characters long, it's 26 to the 15th power, which is roughly 1.7 times 10 to the 21. I rounded off a little bit, but it's going to make it easier for our calculation. Then we want to figure out how long it'll take for 15 characters. So we'll just divide it by that, and we will get, after doing the calculation, I got roughly 4.65 times 10 to 6. So 4 million hours. It makes a huge difference adding those 5 extra characters because there's just so many different combinations it has to go through. So we can see there's a significant difference in adding more characters to your password. The longer your password is, the longer it's going to take to crack because there's more combinations. This number is significantly bigger than 10 characters. But we can make our passwords even more secure. 531 years, yeah, your password's probably not going to get hacked within your lifetime. But let's make our password even more secure. Don't you get annoyed when they tell you that your password should require at least one uppercase and one symbol? Well, there's actually a reason why they do that. So let's just, for example, say we only have to add at least one uppercase. So we are going to do 10. So 10 slots. 1, 2, 3, 4, 5, 10, right? Now, for uppercase, there's one uppercase per lowercase in the alphabet. So instead of it checking 26 times, it's going to check 52 times for each spot. So this could be like an uppercase A, and this could be a B, and this could be an uppercase C, and this can be like a Z, and then like a Z. That's uppercase. So each time, the computer's gonna have to check 52 different things per spot. And it has to get in an order. So in reality, it can go capitalize A, B, C, D, E, F, G, and then that doesn't work. So this is gonna go capitalize A, B, C, D, or this is gonna be capitalize B, so it's gonna go capital A, capital B, then C, D, D. So it's gonna check every single possible combination until it gets your exact password, right? So instead of 26 to the 15th power, or we have 10 spots, we're going to do 52 to the 10th power, which is roughly 1.45 times 10 to the 17 different combinations that a computer has to check, which will take roughly about 17 days. Just adding lowercase. So if you look previously, it took about almost 30 minutes to crack it if you just did only lowercase for 10 letters. But if you do uppercase and lowercase, it'll take about 17 days. You see that right there, 17 days. And then obviously if you add symbols, you're going to add more to this number, which is going to significantly increase this number. So the amount of combinations was going to increase how long it's going to take to crack your code. So I'm going to do one more example to show you how you should structure your password. Now the best password is going to be something that uses uppercases, lowercases, and symbols, and numbers. Using all of these, so there's 26 of these, 26 of these. Let's just assume that we can only use 5 different symbols, and there's 10 different numbers, because 1 through 9 and 0. So let's add these together. So it's 52 plus 15, which is equal to 67 characters we can use. Then we also want to be at least 15 characters. So 1, 2, 3, 4, 5, ... 15. So this is 1, 2, 3, 4, 5, ... 15 characters long. Right? So you see that. All right. So now when we do it, we have 67 from each spot to the 15th power, which is roughly 2.46 times 10 to the 27 combinations. To put this into perspective, this is about half as many atoms are in our body. So if you think about it, a computer is checking half the atoms in our body for our password. That's how many combinations there are. This type of password would take approximately 780 million years to crack. I don't think your password is ever going to get stolen if you follow this. That's if we were just using these. There's probably even more symbols you can use. That's using math to show you how secure your password could possibly be. Now I'm going to show you a website that kind of does the math for you, and you can check your own password. So we're on this website called howsecureismypassword.net. We're going to start off with our first password that we tried out, which was Bruno, N-R-O-B-U. So according to this website, my 10 character long, all lowercase, would take about 58 minutes. So I don't know exactly how many passwords per second it's using to calculate theirs. So mine took about 24 minutes. So my computer is probably twice as strong than what they used here. Computers are getting stronger and stronger as time goes by. So just taking account that it's roughly around this amount of time. So now we can add, let's just see, like with the uppercase. So we'll just do one uppercase and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is just 10 random characters I chose. It'll take about a month. Mine was about 17 days. So like I said, my computer's probably 2 times faster than theirs that they're using to calculate. And then finally, my ultimate 15 character long password with uppercases, lowercases, symbols, and numbers. Let's try to check it out in here. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is just the random stuff with uppercases, lowercase, symbols, and numbers. According to their website, it'll take 15 billion years. Mine was 708 million years. So it still works out that mine's 2 times faster than theirs. But it's still, I would rather use my computer. Imagine using the fastest computer to check your passwords. That's just gonna, because not everybody, I mean, you never know. You never know if someone has the fastest computer or not. So just might as well try it out. But this is just kind of an easy website to go check, see if your password is secure. I don't know how comfortable y'all are with putting your password into a website, especially a .net. So maybe don't exactly put your exact password, but maybe something you were thinking about, or maybe just change a little bit. But it doesn't even really need necessarily to be like that. So if I know my password has one uppercase, one symbol, and it's 12 characters long, I can put that in here just randomly. So like one uppercase, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then one number, 12. See, that's not my exact password, but it includes one number, one uppercase, and the rest are lowercase. It's going to take about 100,000 years to crack. So you can use this website to kind of gauge how long it's going to take instead of actually doing the math on paper. But hopefully y'all enjoyed that and you guys learned something and maybe change your password. It is important, especially if you're dealing with your money or like something financial. It's important to have a nice secure password. So hopefully you enjoyed my math and show how secure your password really is. Other than that, peace out.